Hello everyone, we're going to look at weight and mass in the video today. These are two quantities in physics that are often confused. Usually when people discuss their weight, they often give their number in kilograms, which is actually their mass. So we need to be very careful in physics to make sure we're using the right quantities in the right situations. Weight is a force of gravity acting upon an object, and because it's a force, it's measured in newtons, whereas mass is a physical matter that an object is made up of. It is measured in kilograms. If we were to move to a different gravitational field strength, our weight would change, but our mass would remain the same. The weight of an object depends on how much gravity is acting on the object's mass. If your mass increases, your weight increases. However, you could be in a situation where your weight increases or decreases, but your mass stays the same, and that's when you move into a different gravitational field strength. We can look at how weight and mass are related using the equation that's on the screen now, where the weight is equal to mass times the gravitational field strength. Weight's a force, remember, so it's measured in newtons, mass is measured in kilograms, and the gravitational field strength is measured in newtons per kilogram. We use the symbols to make it easier for us to apply in physics, and so we use W for weight, M for mass, and G for gravitational field strength. And if you remember the unit symbols, we've got N for newtons, kg for kilograms, and N/kg for newtons per kilogram. And you should be aware that on Earth, at GCSE, we need to use the gravitational field strength on Earth is 9.8 newtons per kilogram. And sometimes they'll try to make the question harder by having you recall this fact. This brings us to the end of the theory on this section now, so we're going to look at some practice questions in a moment, but you should be able to answer questions 1 to 3 on your worked example sheet. We're now going to look at question 4 on your worked example sheet. Remember that questions 1 to 3 should be answered already with the previous part of the video, so if you haven't quite got the answers to all of those questions, please rewatch the first part of the video in order to answer questions 1 to 3. In question 4, we're going to look at using the weight equation to complete calculations. If we look at the equation that's on the screen now, it says a bowling ball has a mass of 7.3 kilograms, and it wants you to calculate the bowling ball's weight. And that's all the information it gives you. So I'm going to write down first of all that we've got a mass, M, is equal to 7.3 kilograms. And I want to know the equation that links weight and mass together. And that is that W equals, which stands for weight, equals mass times by, and in this case, it's going to be gravitational field strength. Okay, now, which has the symbol G. With gravitational field strength, that's one that you need to recall. So the gravitational field strength, remember, is equal to 9.8 newtons per kilogram. And then I can go through and substitute those numbers into my equation. So W is going to equal 7.3 times 9.8. So then my weight equals, I'm just going to put those numbers into my calculator, and that would equal 71.54. I'm probably going to just round that up to 72 newtons. And that would be my answer. So I'm going to go back through now and just show you where you get the marks for. So you'd have 1 mark for recalling the 9.8 if you were looking at it early in the equation, early in the paper. You get another mark for substituting the numbers in, a mark for the correct answer, and a mark for the units. So that would probably be worth about 4 marks. If it came early in the paper, if it was later in the paper, it'd probably only be worth 2 or 3. So I would like you to pause the video there and attempt questions 5 and 6. Once they've been completed, you can come back and watch the video just to see if you got them correct. So hopefully you've completed question 5. If you haven't done so already, please pause the video now and complete question 5. Okay, I'll run through question 5 with you. So it's very similar to the one that we've just gone through. It tells you here that a football has a mass of 0.45 kilograms. So I'm just going to write that down, that mass equals 0.45 kg. It wants us to calculate the weight of the ball. So I write out the equation, recalling that from memory, that weight W equals mass M multiplied by gravitational field strength G. Then remember that gravitational field strength is equal to 9.8 newtons per kilogram. Putting those numbers in, I get that weight is equal to 0.45 multiplied by 9.8 So my weight equals, I just put those numbers into my calculator. That comes out with an answer of 4.41 newtons. I'm going to round that to 4.4 because I've got two significant figures in the question. And that's my answer. Going back through to show you where the marking comes from, you can please mark this. You get a mark for recalling that gravitational field strength is 9.8 on Earth. You get another mark for putting the numbers into the equation, a mark for the correct answer, and a mark for the correct unit. So you can give yourself a score out of 4, please. 4.4 newtons will get you all 4 marks. Okay, we're on question 6. Remember that you should have completed question 6 already. If you haven't done so, please pause the video now and just complete question 6. Okay, hopefully that's completed. I'm going to run through the question with you again. Okay, it says in athletics, the hammer used in the hammer throw has a mass of 7.26 kilograms. I'm going to write that down, that mass equals 7.26 kg. I remember the equation that links mass and weight, where weight W is equal to mass M multiplied by the gravitational field strength G. Because it's on Earth, I recall that G is equal to 9.8 newtons per kilogram. Once I got that information, I'm going to put the numbers into the equation. So W will equal 7.26 multiplied by 9.8. Again, we just put that numbers into our calculators to find that weight equals. And once I put that into my calculator, I find that weight is equal to 71.148 newtons. I got three significant figures here in the question, so I'm going to round that up to be that weight will be 71.1 newtons. In terms of marking, a mark for remembering that 9.8 is gravitational field strength on Earth, a mark for substituting the numbers into the equation, 1 mark for the correct answer, and 1 mark for the correct unit. If you're at 71 newtons here, you could also get yourself all 4 marks. It doesn't need to be 3 significant figures at GCSE, but that would be the quantity you should quote it to if you're doing A-level, because I've got 3 significant figures in the question. Okay, we're going to move on to question 7 now. Question 7 I'm going to do is a worked example so you can follow it on through, and afterwards you can then try 8 and 9 as by yourself and then just check your answers afterwards. Okay, so question 7 is going to involve us rearrange the equation. So it says the Olympic and world champion boxer Nicholas Adams has a weight of 470.4 newtons. That's the approximate weight that I've used based on her weight class. So 470.4 newtons is her weight. So we'll write that down, 470.4 newtons. And notice the weight is measured in newtons, that's the important thing. It wants you to calculate her mass. I'm just going to use the same colours as I was before. So I write out the equation that W equals M times G. I remember that G, gravitational field strength, is 9.8 newtons per kilogram. Okay, I'm then going to put the numbers in. So I get 470.4 equals my mass M multiplied by my 9.8. Now here, I'm going to rearrange the equation. So I've got this times on this side. I'm going to take it over and divide on the other. So I get 470.4 over 9.8. That's going to equal M. And now I can put that into my calculator and do 470.4 divided by 9.8. And when I put that into my calculator, I currently answer that my mass is equal to 48 kilograms. Okay, looking at marking points here, so I get 1 mark for remembering that G is equal to 9.8 newtons per kilogram. I get 1 mark for putting the numbers into the equation. I get a mark for the rearrangement, a mark for the answer, and a mark for the unit. So that would give you a score out of 5 for these questions. So I'd like you to pause the video there now and you complete questions 8 and questions 9, and I'll come back and go through them with you once you restart the video. So this is question 8. Remember, you should have completed this already. If you haven't completed it, please pause the video and have a go yourself, and then watch the video to see how you get on. Should run through this one with you now. So it says a motorbike has a weight on Earth of 3,208 newtons. So my weight W equals 3,208. Okay, now I want to recall the weight equation. So I'm trying to find out the mass. So my weight is equal to my mass M multiplied by my gravitational field strength G. Remembering that G is equal to 9.8 newtons per kilogram. So putting the numbers in, I get 3,208 equals the mass that I'm trying to find out multiplied by 9.8. Because this is a times on this side here, remember this times here needs to be used as a divide on the other side. So I get 3,000, get the right pen on, 3,208 over 9.8 equals the mass. So that means that my mass is equal to, I just need to put that into my calculator to find mass. Here you're going to get a long number for mass, so you can write that whole thing down. I should need to move my mass further up. So put that into your calculator, you find out that mass is equal to 327.4, and it goes 346.939 and keeps going. So I'm going to round that up. I've got 4 significant figures here, so that'll be 327.3 kilograms. Okay, in terms of marks, 1 mark for recalling a 9.8, 1 mark for substituting the numbers into the equation, 1 mark for the correct rearrangement, 1 mark for the correct answer, and 1 mark for the correct unit. So give yourself a score out of 5 for that question, please. We're now going to look at question 9. Remember that this is one of the questions that you should have completed already. So if you haven't completed it, please can you do so now by pausing the video, complete the question, and then restart the video so we can go through the answers. Same format as before. For this question, it says the large African elephants can reach weights of 35,280 newtons. So my weight, W, equals 35,280 newtons. I want to calculate the mass of the elephant with this weight. So I'm going to use the equation W equals M times G, where remember that G is equal to 9.8 newtons per kilogram. So putting the numbers in, I get 35,280 is equal to M times 9.8. Doing the rearrangement, I get 35,280 over 9.8 is then equal to M. My mass will equal, I just need to put that number into my calculator. So my mass here equals 3,600 kilograms. Going through the marking criteria, just to make sure this is correct. 1 mark for remembering that G is 9.8 newtons per kilogram. 1 mark for putting the numbers into the equation correctly. 1 mark for the correct rearrangement. 1 mark for the answer, 1 mark for the unit. So can you give yourself a score out of 5 for that question, please? Okay, so here's question 10. It says a household hammer has a mass of 0.25 kilograms. On the moon, the hammer has a weight of 0.4 newtons. I want you to calculate the gravitational field strength on the moon. So let's run through that. We've got here that mass is 0.2, so mass M is 0.25 kilograms. My weight is 0.4 newtons, so weight W equals 0.4 newtons. The equation, remember, is that weight W equals mass M times gravitational field strength G. Now with this question, we're trying to find out G this time because it's not on Earth. So G, gravitational field strength G, is only 9.8 if this is on Earth. So let's put the numbers in that we've got. So we've got 0.4 equals 0.25 times by G. Now we can still see that on this side we've got the times here. So to change side, we need to divide it, use a divide. So to get rid of the 0.25 multiplied by G, we're going to divide 0.4 by 0.25. So that equation becomes 0.4 over 0.25. And that is equal to G. So G then equals, we put our number into our calculator. So on the moon, we get gravitational field strength of 1.6 newtons per kilogram. And that might come in useful later. Just showing you how you get the marking points here. 1 mark for substituting the numbers in, 1 mark for the correct rearrangement, 1 mark for your answer, and 1 mark for your unit. So a score out of 4 for that question, please. So I'd like you to pause the video there and you complete questions 11, 12 and 13 by yourself. Once you've completed those questions, you can restart the video and then I'll go through the answers with you. So this is question 11. Remember that you should have completed this yourself already. So if you haven't completed question 11, please pause the video now and give it a go and then restart the video to go through the answers. So in question 11, it says a typical mobile phone has a mass of 0.221 kg. So my mass M equals 0.221 kilograms. Okay, the next bit is that my weight is 5.46 newtons. And we now want to find the gravitational field strength on Jupiter. So it's not on Earth, so we know that weight isn't 9.8. So we get W is equal to our mass M multiplied by our gravitational field strength. That's just recalling the equation. So gravitational field strength G. We put the numbers in. So our weight W is 5.46. That is equal to our mass of 0.221 multiplied by our gravitational field strength G. So we need to take the times to the other side by dividing. So that's the opposite of a times. So 5.46 over 0.221 is going to equal our gravitational field strength. Now you just need to put those numbers into the calculator then to find out what gravitational field strength is. So we're going to do 5.46 divided by 0.221, and that would give us an answer of 24.7 0588, and it keeps going. So you can round that up, so G becomes equal to, in the question, we've got 3 significant figures for both our mass and our weight, both to 3. So we're going to make sure that we do that one to 3, so that's going to be 24.7 newtons per kilogram. Going through and showing you where the marks come in, we get a mark for putting the numbers into the equation, a mark for the correct rearrangement, a mark for our answer, and a mark for the unit. So again, give yourself a score out of 4 there, please. We're now on question 12, sorry. What I'd like you to do is make sure that this is completed beforehand. So if you haven't completed question 12, please pause the video now, complete the question, and then restart the video to listen to the answer. Because this is an interesting question regarding the Venus Express, which was an orbital launched by the European Space Agency in 2005. It successfully orbited Venus from 2006 to 2014. And if it has a mass, remember our mass M, of 93 kilograms. I'm just going to write that down so I know that one. And if on Venus it has a weight of 818 newtons, we want to be able to calculate the gravitational field strength on Venus. So we're no longer on Earth, so we're not going to use 9.8. We're going to use a different value of gravitational field strength, which we need to calculate. So first of all, we're going to need the equation that W is equal to M times gravitational field strength G. Put the numbers in, 818 equals 93 times gravitational field strength. So to successfully rearrange the equation, we've got 93 times G. So to get rid of that, we need to divide. So we're going to get on the opposite side, we're going to 818 over 93. And that's going to equal our gravitational field strength G. And we can put that number into our calculator to find out our answer. So putting that number into our calculators, we've done 818 divided by 93, we get 8.795698, and so on and so on. So you can round that up. In the question, we've got a weight of 818, which is 3 significant figures, which means that our gravitational field strength G is equal to 8. It would be 8.79, which would round up to 8.80 newtons per kilogram. Looking at how to mark a question, we get a mark for putting the numbers into the equation, a mark for the correct rearrangement, a mark for the correct answer, and a mark for the correct units of newtons per kilogram. So for Earth, okay, question 13 then says, which of the three astrological objects G equals 9.8 newtons per kilogram? Mass to Earth. If we go back through the other questions, the moon has a value we found out to calculate. You can look at your questions more easily than me, but the moon, it was G was equal to 1.6 newtons per kilogram. Jupiter, G was equal to 24.7 newtons per kilogram. And then we had Venus, which was to 8.8 newtons per kilogram. So of these ones, which one has the closest to Earth? Well, the closest to 9.8 is Venus. So therefore, Venus has the most similar gravitational field strength to Earth. So Venus has the most similar mass to Earth. And that would be the answer to that question. So the answer to the question is Venus, because it has the closest gravitational field strength to the gravitational field strength of Earth. Thank you very much for watching the video today. I hope you found it useful. I look forward to working with you again in the future. Thank you and goodbye.